So what we're going to do now is we're going to apply some of the ideas we talked about in that previous video to a few example problems. And we're going to start off by looking at this triangle here that we have on the coordinate plane. And we can see that we have the coordinates of each corner. So A is at 1, 6, B is at 3, 1, and C is at 8, 3. And the first thing we're going to do is find the length of segment AB. That's what this means. Remember, if it just says find AB, it means find the distance between points A and B. And the formula that we're going to use is the distance formula. Now remember, the version of the distance formula I want you to remember says that the distance between 2 points squared is equal to the change in the x coordinates of those 2 points squared plus the change in the y coordinates squared. Remember that this delta here, this triangle, it's called the Greek letter delta, and it means the difference between or the change between. So this notation is saying, look at your 2 x coordinates and how far apart are they. Take that number and square them. Look at your 2 y coordinates. How far apart are they? Take that number and square them. And that's the distance squared. So we can rewrite that by square rooting both sides, and we would have the distance, oops, I said distance squared again. Let me just get rid of that because I'm square rooting each side, so that squared is going to be gone. The distance is going to be equal to the square root of the change in x squared plus the change in y squared. So let me write my 2 coordinates over here, 1, 6 and 3, 1. And let's look at the change in x first. The change in x would be the difference between 1 and 3. So I think of that as taking 3 minus 1, and I'll get 2. Now I could do 1 minus 3 and get negative 2. Right? I could think of that change as being a negative 2 change if I think about going from 1 to 3. Right? That's like a negative 2 change or a negative 2 difference. But it doesn't really matter whether I use 2 or negative 2 for change in x. The reason is I'm going to end up squaring that. And when I square 2, I get 4. And when I square negative 2, I get 4. So it doesn't really make much of a difference whether I think of that change in x as a 2 or a negative 2. Now, later on, we're going to do a problem where we use the slope formula. And the slope formula also uses this notation of change in y and change in x. But in that formula, it does not get squared. So we do have to pay attention when we do slope to whether we should be subtracting, for instance, 3 minus 1 or 1 minus 3. But for now, in the distance formula, it doesn't really matter since we're going to square it anyway. Now let's do change in y. I'll just do 6 minus 1 and get 5. So now I'm going to take those two amounts and put them into my distance formula. Distance will be the square root of the change in x squared plus the change in y squared. So that's going to be a distance of the square root of 4 plus 25, which is the square root of 29. And I could leave it like that as an exact answer. Or I could do the square root of 29 in my calculator and approximate that to say 5.4. So the square root of 29 is about 5.4, and so that tells us the length of segment AB is about 5.4. The next question uses the same triangle, same corners, and it asks, how would we find the point that bisects segment AB? Well, to bisect it means to cut it exactly in half. It looks like it's somewhere around here. That looks to be about the halfway point between A and B. But of course we could use the midpoint formula. And our midpoint formula says that our midpoint will be at x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So again, I'm going to write off to the side here. I'm going to write my coordinates of A and B. And then I'm going to say my midpoint will be the 1 plus the 3 divided by 2. That'll be the x coordinate of the midpoint. And the 6 plus the 1 divided by 2 will be the y coordinate. So my midpoint will be at 4 divided by 2, 7 divided by 2, which would put it at 2, 3.5. Now I always just want to make sure that that answer would make sense based on the picture. If I graphed the point 2, 3.5, it would put me right about there, which does indeed look like it's probably the midpoint between A and B. The next problem asks, again, same triangle, How do the slopes of line segment AB and line segment BC show that the measure of angle ABC equals 90? Well, let's calculate the slope of each of those 2 points. So the first thing I'm going to do is I'm going to do the slope of segment AB. Remember, little m means slope, so the way I write it is m parentheses segment AB, which to me means the slope of segment AB, would be the change in y's over the change in x's. And again, off to the side, I just like to have them here. Let me rewrite those coordinates. Now when I do the change in y's and the change in x's, since again, I said this before in example 1, but since I'm not squaring these, I do have to pay attention and make sure that I subtract them in the same order. So I'm just going to subtract them from top to bottom the way I have it written over here. So I'm going to be doing 6 minus 1 for change in y and 1 minus 3 for change in x. That's going to give me 5 over negative 2. Which normally we would write that with the negative sign kind of in the middle, so I'll say negative 5/2 is the slope of segment AB. Now let's go ahead and do the slope of segment BC. So point C is at 8, 3. Point C is at 8, 3. And again, I'm going to do change in y over change in x. So now I'm looking at these 2 points. When I subtract the y's, I'll do 1 minus 3. 1 minus 3. And when I subtract the x's, I'll do 3 minus 8. This one minus that one. And so that's going to give me negative 2 on top, negative 5 on the bottom. Those two negatives would cancel out, so I would have 2/5. So the question is, how does these two slopes show that this is a 90-degree angle? Well, if I look at these slopes, I notice that they are opposite reciprocals of one another. This one is a negative, this one's a positive, and then 5/2 here, 2/5 here. The numerator becomes the denominator, and the denominator becomes the numerator. So that's how it shows us that that's a 90-degree angle. It says the slopes are negative 5/2 and 2/5, which are opposite reciprocals. Therefore, segment AB is perpendicular to segment BC, and the measure of angle ABC would be 90. Example 4 says, given triangle ABC, same triangle, what is the length of the line segment connecting the midpoints of segment AC and segment BC? So that would be this blue segment here. How long is that segment? Now we have 2 options here. We could either find the coordinates of those midpoints and then use the distance formula to subtract that, or we could remember that we learned a theorem that says that this segment, called the mid segment connecting the midpoints of 2 sides, is going to be half as long as the third side of the triangle. So we could either remember back to what we found for the length of AB and just divide it by 2, and that would be the length of this blue segment, or again find these coordinates and use the distance formula. I'm going to go ahead and first do the method where I just think about the segment AB's length and divide it by 2. Because in a previous problem we found the length of segment AB, and we said it was the square root of 29, which was approximately about 5.4. And if I go ahead and let's label this segment as segment DF, then segment DF's length would be square root 29 over 2, if I wanted to give it an exact answer, or approximately 2.7 if I went with the decimal answer. So that's obviously the shortest way to do that, but it requires you remembering that that mid-segment has half the length of the third side. Now, of course, the other way we could do this is to find the coordinates of D and F, the midpoints of segment AC and segment BC, and then use the distance formula. So just to show you that we'll get the same answer either way, let's go ahead and do that. The coordinate of point D would be the average of the x coordinates and the average of the y coordinates for the endpoints of the segment that it's the midpoint of. So in other words, I'm taking A's x coordinate and C's x coordinate, adding them together, dividing by 2. and then doing the same thing with each of those points' y coordinates. So that gives me 1 plus 8 over 2 and 6 plus 3 over 2. Both of those are going to end up being 9 divided by 2, which I'll write as 4.5. So D is at 4.5, comma 4.5. F is at an x coordinate of 3 plus 8 divided by 2 and a y coordinate of 1 plus 3 divided by 2, which would give it a coordinate of 5.5, comma 2. 3 plus 8 is 11. 11 divided by 2 is 5.5. 1 plus 3 is 4, and 4 divided by 2 is 2. So now if we're going to find the distance from D to F, we are going to take the square root of the change in those 2 points x's plus the squared plus the change in those 2 points y coordinates squared. So that's going to be the square root of, well, the x coordinates are 4.5 and 5.5, so that's a difference of 1 squared. The y coordinates are 4.5 and 2, which is a difference of 2.5. So now this turns into the square root of 1 plus 6.25, or the square root of 7.25. And if I type the square root of 7.25 in my calculator, I get about 2.7. So you can see I could have done this route, finding these coordinates and then finding the distance between them, or this route, which means I just need to remember that that would be half as long as this segment. Now in this last example, it asks us if this triangle, which is a new triangle, not the same one as we had before, is it equilateral, isosceles, or scalene, and is it a right triangle? Now the first question talks about the lengths of the sides, because equilateral triangles have all sides the same, isosceles have 2 sides the same, and scalene means that they're all different. So we're going to start this problem by finding the length of xy, the length of yz, and the length of xz. And we're going to use that distance formula where we take the square root of the change in x squared plus the change in y squared. So the change in the x's, but for x and y, is a 1 minus 5, which has a difference of 4. And then the change in y's for those is, well, it goes from 2 to 8, which is a difference of 6. So we're looking at the square root of 16 plus 36, which is the square root of 52. And we can just leave it as this exact answer, square root 52. For y to z, our x's are different by 3. One's a 5 and one's an 8. And the y's are different by 2. One's an 8 and one's a 6. So this is the square root of 9 plus 4, which is the square root of 13. So you can see right away we can eliminate equilateral, which looking at the picture we probably could do that anyway, because those two are not the same length. But it might still be isosceles, so let's find the length of xz. That would be the square root of, let's see, the x's are 1 and 8, which is a difference of 7. And the y's are 2 and 6, which is a difference of 4. So that would be the square root of 49 plus 9, which is the square root of 58. So you can see all 3 sides are different lengths. So that means this triangle is scalene. It has 3 sides that are all different. Now to figure out whether it's a right triangle, we're going to look and see if there's a right angle. Now if there were a right angle, it would be across from the longest side. And the longest side is segment xz. Square root 58 is the longest of these 3 distances. Which means that the only one that might be a right angle is this angle, angle XYZ. And to find if that's a right angle, we are going to compare the slopes of the 2 sides that would make that angle. So that would be segment XY and segment YZ. We're going to compare those 2 lines' slopes. First, let's take a look at the slope of segment XY. So remember, to find the slope, we're going to take the change in y over the change in x. And remember, it does now kind of matter which order we subtract things in. We just have to be consistent with from the top to the bottom. So for instance, from x to y, the y's go from 2 to 8. So we'll do 2 minus 8. That's the y coordinate of x minus the y coordinate of y. So this one minus that one. And then for the change in the x's, we'll do the same thing, 1 minus 5, going from this one, subtracting that one. And so that's going to give us negative 6 on top, negative 4 on the bottom, which is going to simplify to 3 over 2. The negatives will cancel each other, and then I can divide top and bottom by 2 to get the fraction 3/2. Okay, now let's do the segment YZ slope. So I'm going to do, again, change in y over change in x. So for y to z, the y's are 8 and 6, and the x coordinates are 5 and 8. And so 8 minus 6 is going to be 2, and then 5 minus 8 is going to be -3. So this would be usually written as -2/3. We would take this negative sign and move it kind of towards the middle of the fraction. And now we see here that the two segments that we were looking at have slopes that are opposite reciprocals. They are one positive and one negative, 3/2, 2/3. And so that tells us that this angle right here is in fact a 90-degree angle because those two segments are perpendicular. So if this is a 90-degree angle, we can say yes, triangle XYZ is a right triangle.